Alright, evaluate the integral x squared natural log of x dx. Now there are two methods that we can use to work out an integral like this one. We can't use u substitution because if we do, nothing is going to cancel out. That's the aim of u substitution. So the first one we can use is the tabular methods, and that's obviously the simplest. We're going to have a column of signs, derivatives, and integrals. So what we are doing is we are dividing this. We have got this first one and we have got this second one. Now the thing is, which one can we put under the derivative such that if we differentiate we're going to have a constant, and which one can we put under the integral such that when we integrate is going to be easy? So what do you think? Which one is going to be under the integral and which one is going to be under the derivative?
I think for the I think x squared, and then the other one, the other side.
I didn't get that.
And the one for the derivative, I think we can get x squared and the remaining one on the other side.
Okay, so this is the only case where you can't get natural log, you put it under integration because you don't know the integral of natural log of x. Like you need to use this method just to find the integral of natural log of x. So you can't put, or maybe you know what's the integral of natural log of x? So you can't put natural log under the integral. For natural log, always put it under derivative. So if this was maybe x squared e to the power maybe x, would have put the e to the power x under the integral, but not natural log. You don't do that. So what we're going to do is now differentiate natural log. When you are differentiating logarithms, okay, when you are differentiating logarithms, just differentiate this. That is going to give you a 1, and then the same thing that you differentiated, write it in the denominator, okay, and then integrate this one. That is going to give you x, add the 1 power 3, the same power 3, bring it down. Is this okay?
Yes.
Now if you continue differentiating this one, the power in the denominator will continue increasing. If you continue integrating this one, the power also continue increasing. So we just end there. This will be positive, this will be negative. So therefore we are saying the integral of x squared natural log of x dx is going to be equal to, multiply this times this, we multiply in the diagonal times that. So that is going to be x to the power 3 over 3 and then natural log of x. Okay, so we can see this, we only have one diagonal we can multiply. We don't have another diagonal. Since there is no 0 here, what we are going to do is we also multiply in the horizontal like this. So that will be negative, okay, 1 over x times x cubed over 3. You can see that 1 x can cancel with 1 x there. That is going to give us x to the power 2 over 3. But every time you are multiplying in the horizontal, you need to add an integral here. Because there's an integral, always make sure that you have got dx there. Are we okay there?
Yes.
Alright, so after then, now we can say this is equal to x to the power 3 over 3 natural log of x minus, I'll bring out the 3 in the denominator because they're constant outside the integral. Then we remain with the integral of x squared dx. So this is going to give us x to the power 3 over 3 natural log of x minus 1 over 3 integral. Now integrate x to the power 2, that will give us x to the power 3, the same power 3 over 3. Then add the constant c. So this is going to be x power 3 over 3 natural log of x minus x power 3 over 9 plus c. So this is going to be the answer. Okay, are we okay? So apart from
Yes.
Apart from you using this method, the tabular method, you can use integration by parts. Now integration by parts, it comes from the differentiation, like that. The what rule is that? Is it the product rule? Yeah, it comes from the product rule. If you have got dy over dx, this is equal to v du over dx, then minus u dv over dx. Is it minus or a plus? It's a plus there. Okay. Now since everything is or with a dx down, we can cancel out that dx down. So we're going to have dy being equal to v du and then plus u dv. Now from the alphabet, u comes first and then v, right? So I'm going to make sure that the one which has got a u and then dv is subbed to the formula. So this is going to become, okay, I'll put u dv, this is the one, this is going to be equal to dy, which is this one here, okay, and then I'm going to take this term this side. That is a what? That is minus v du. That is how it becomes, okay, like that. Now from here, what we do is we are going to integrate everything. We're going to integrate just everything. So what we are going to do is we introduce the integral symbol here, here, and also here. So what we are going to see is we are going to have the integral of u dv being equal to, what's the integral of dy? Like when you are integrating 1 with respect to y, you are going to get what? You are going to get y, right? So we're going to get y here. And then minus, what is the integral of v du? Because we're integrating with respect to y, that means all others are constant. So this will just be integral of v du the same way it is. Is this okay?
Yes, it is okay.
Now, because you were differentiating, remember before to have v and u, it means you are differentiating a what? A product. So you had y, you had something which is like in the form y is equal to u multiplied by v. Okay, this is a product. So where there is y, we can put uv, since you are differentiating a product. So this becomes the integral of u dv is equal to uv minus the integral of v du. So this is the formula that we use when you are differentiating by, integrating by parts. So that is what we are going to write. So we are saying the integral, the first letter in the alphabet is u, and then dv is going to be equal to uv minus the integral. Now you're going to have v and then du. Now here you need to find u. Okay, just this one that you've been given here, just this one you have here, one term and the other one. You need to know that one is going to be u and then the other one is going to be dv. Okay, the other one is going to be dv. So you can say, okay, let's say if u is the first one, if u is this one, x squared, then that means that dv, okay, the other part dv is going to be everything that has remained, natural log of x dx. You get that?
Yes,
That means that if I want to have v, if I want to have v, since I've got dv here, I need to integrate both sides. Integrate here and also integrate here. So the integral of v, okay, like dv. In other words, we're integrating, there's a one in front here which you can't see, but you're integrating with respect to v. Just like if we say the integral of dx, this is going to give you x. The integral of dy is going to give you y. The integral of dv is going to give you v. So the integral of v is going to be v. Now the integral of natural log, we don't know. That is why for this one, we're not going to make u be equal to x squared and dv the other one. So instead we are going to say this first one, which is u, we are going to say let u. So you should always make sure that the dv is something that you can easily integrate. So u is going to be this one, which is difficult to integrate. Okay, now you just get natural log, don't get together with the dx. So u is going to be natural log of x. That means now the second part, which is the dv, is going to be everything that remained. So dv should always have dx. So it's going to be x squared dx. Okay, now that we have found this, now to find v, we are going to integrate both sides. The integral of dv, we saw that that is going to be v. The integral of x squared, just add a 1, that becomes x to the power 3, and then divide by the same. Okay, don't need to add the constant. The constant what? The constant c. Now here we also need, remember we have a du here and we have u there. So we also need to find du. How do you find du? Du, just differentiate this one. That's the meaning. Okay, differentiate natural log of x. That's du. Like just like if you are finding dx, means find the derivative with respect to x. So we're going to differentiate natural log of x. How do you differentiate that? Just differentiate this x, you get a 1, and then over the same thing that you differentiated, which is the x. But every time you differentiate you are differentiating u, but remember it is with respect to what letter you're differentiating x. So always remember to add a dx here, and then you come and substitute here. So this will be the integral u dv, that is the question we've been given, x squared natural log of x dx, is going to be equal to, what is u? We found u as natural log of x. What is v? We've determined v as x to the power 3 over 3. Then minus the integral of v. What is v? We've determined that is x to the power 3 over 3. And then du. Okay, what is du? Du, we found that is 1 over 3 dx, just this one here. So this gives us x to the power 3 over 3 natural log of x minus, we can see that 3 times 3, that is that something that I've left out? So I was supposed to write 1 over x. This was supposed to be 1 over x. Remember substituting du, and du is 1 over x dx, not the 3 that I wrote. Okay, 1 over x here. So 1x is going to cancel with 1x there. Okay, so that will be negative. The integral, we're going to have just x squared on top, and then we're going to have this one, which is the what? Which is the dx. Now instead of me having a 3 and the 1 there, I'm going to write that outside the integral 1 over 3. So this is going to be x to the power 3 divided by 3 natural log of x minus 1 over 3. Now integrate x to the power 2, that will be x to the power 3 over 3. Now just add the constant c. And this gives you the same answer which we had, x power 3 over 3 natural log of x minus 3 times 3, that is a 9, then plus a constant c. So that is it.